people in the antenatal clinics or just the general population. You take a test, you do a screening, and you said, oh, we have a suspicion you may have this. Now go and get confirmed. And after that, how do you actually go about doing prenatal diagnosis and genetic confirmation was not known. We changed that here. We actually got this fancy lancet that made it much easier for people, to give samples. Not only that, this lancet allowed us to collect an adequate quantity of blood that could go not only from screening, but all the way to a genetic diagnosis, for which we established a new technology where 1 microliter of blood would give you the mutation in the beta globin gene. And then we set up a whole software that would track this from the ASHA worker in the field, collecting it and entering it on the tablet in the field in Odisha, to the central data monitoring system, to the sample reaching the lab, getting the HPLC report. Within a week, we turn that around, send it back to the ASHA worker, who would convey it to the lady who is pregnant and is in the antenatal clinic, to call her partner, her husband, for the husband to be screened and that to be confirmed, all within 2 to 3 weeks, because then they have to go for a prenatal diagnosis if both partners are carriers. So this is something as a system that was established within the Odisha healthcare system, and this is something that actually was quite unique. So this program, did set up a model for establishing such a program in the country, and this in some way needs to be expanded now to the future. I want to take you through now. We tried allogeneic transplant, we tried a control program, and now we want to develop alternative, curative programs. So what is gene therapy? A particular gene does not function in your body, so you can, with molecular biology techniques, construct a gene. And that gene needs to be then carried, into the body, into a particular cell, and that's the vector, which may be a virus or a non-viral method. It is entered into the body, through different routes. It could be intravenous, it could be directly into tissues. And this vector then goes to the target cell, releases the payload, and the transgene may get integrated with your genome if it's an integrating vector, or it may stay episomal and start producing the protein of interest. In this case, the globin gene, the globin or the factor 8 or 9, whatever gene therapy you're doing. There are 2 broad approaches. One where you take the vector and package the transgene outside and inject the vector itself, as I showed in the previous cartoon. And the vector goes to the organ of interest. It may be the liver or some other organ, and then starts making the protein, in this case factor 8, as shown here. Or you take stem cells out of the patient and you process it in the lab, and you introduce the transgene in the lab into the stem cells, and then you do an autologous transplant to put the gene-modified stem cells back. The second approach is what has been used for the immune deficiency disorders for more than 25 years in the world, and more recently for the major hemoglobin disorders. And the first approach is what has been used for ocular diseases in the past, for hemophilia, and also now for the spinal muscular atrophy, Zolgensma, of which more than 250 doses have been administered in India at a cost of more than $2 million a dose. So these are the 2 broad approaches. Now, in the context of hemoglobinopathy, you can do 2 things. One, the first one just shows you that we are all born with almost total hemoglobin F, and this is the gamma globin that predominates at that point with the alpha chain. And then around 6 months, the gamma chain starts going down and the beta chain starts coming up, and you get the adult hemoglobin. So 2 things to do. Either you put a new beta globin gene and get enough beta chains, or you remove the suppression of this gamma globin gene and allow the gamma globin to start functioning again. So we start living with hemoglobin F again, just like we were living when we were born. So these 2 approaches are there in the world, and I don't have time to get into the details. But what this shows you is the first clinical trial that led to an approval of a product in Europe in 2019. And here is a beta globin gene addition approach. And what you can see is that by transducing their hematopoietic stem cells and doing an autologous transplant, these patients could produce 4 to 6 grams of the adult hemoglobin, adding on to the baseline. And this was approved in 2019 in the European market Unfortunately, the price was too high for the governments, even in Western Europe, to accept this. And so the company Bluebird Bio, pulled it out 2 years later. And then they brought it to the US with some improvement of not the vector itself, but the way the transduction was done of the hematopoietic stem cells. And now you can see that the median hemoglobin due to the transgene has increased from 4 to 6 grams to about 8 or 9 grams. And this was registered in 2021 in the US at a cost of $2.8 million. So this is still available as a treatment for people with thalassemia and sickle cell disease. The other approach was to modify the hemoglobin F. And there were two approaches here. One was to use an shRNA to suppress the transcription factor, BCL11A, which shuts down the gamma globin gene. So if you suppress this transcription factor, the gamma globin gene will restart functioning again, and you will then make more hemoglobin F to live. This approach is still in clinical trials, but the gene editing approach doing the same thing. In some ways, you disrupt the BCL11A transcription factor gene so that the BCL11A goes down and the fetal hemoglobin starts coming up. This started with just example of one patient each in 2019. And 2 years ago in 2024, both for sickle cell disease as well as for thalassemia major, this was approved as a product and is available as a gene editing approach for gene therapy for both hemophilia and, for thalassemia major and for sickle cell disease. The problem for us is that you can see the price highlighted here, $2.2 million for one of these, and the new, the new gene addition vector is at $3.1 million. So this is not something that will ever reach the large numbers of people in the Asian region that require these drugs. So with the support, I go back to that grant that I talked about. On one side, we were doing the field program to try and reduce the disease burden in the community. But on the other side, we were doing the gene therapy research to make our own vectors. And in the next 3 slides, what you see, our colleagues at the Center for Stem Cell Research, Dr. R.V. Shaji here, developing gene addition vectors for both beta and gamma globin genes, as well as an shRNA vector to suppress the BCL11A gene. Dr. Thangavel was taking the CRISPR-Cas9 approach, and Dr. Murugesan was, doing the prime and base editing approach. And we developed almost 6 or 7 technologies, matching all of those that were in clinical trials in the world and more. And it needed to be translated to the industry, and that is where we got stuck, and that's life. We'll come back to that. Now, in the last part, I just want to take you very quickly through the need for hemostasis services and research in the community. Every intern and registrar can order an NGS, and for 6,000 to 8,000 rupees, you can get a genetic diagnosis of just about any disease you want. It wasn't like this 20 years ago. Now, this is another slide that's missing. Anyway, yeah, what I wanted to show you here was when hemophilia is inadequately managed, you get many complications that require surgery. And doing surgery without clotting factors is an absolute nightmare. And so at that time, we had to beg, borrow, not steal, for plasma clotting factor concentrates. And to ask for that, when you plead, if they feel like giving you, they give. If you don't feel like giving you don't get. So you change the narrative a bit. We started publishing our reports, and we started questioning the way hemostasis. On one side, to the World Federation, we said, we are providing surgical services to hemophilia and inherited bleeding disorders for almost 1/5 of the world. This whole subcontinent has that much people. And on the other side, we questioned the protocols for hemostasis. And we said, the world does not know how to do it. We think we know it better. And the moment you say that, people want to look at you. And now they will give you, products to do your work, which will also lead to some science. So this then got recognized at the ISTH. And in 2001, I was asked to come and present our experience, where one of the doyens of hemophilia in the world said, this is not the paradigm for how we do things. And I was daring enough to say, then Dr. Roberts, the paradigms will need to change. And that was a big statement, but then I landed up in the World Federation of Hemophilia, where I questioned about how they were going around the world training people without writing guidelines. And they said, how can you write guidelines? And I said, of course you can write guidelines. And that's how it started, all 3 editions of this International Hemophilia Guidelines, which have, more than 2,500 citations and, more than 1 million downloads. And this actually incorporated our protocols. And we are convinced of our protocols because it's not only in CMC, but all our students who go out in the country are also able to practice that. So it works. So we now have the first guidelines in the world where you have 2 sets of doses, those which are called the low practice pattern and the higher dose practice pattern. And this is something interesting. Now in hemophilia, because of all the advocacy we have and the registry I initiated in the late 90s, we have about 30,000 patients registered. And this is a very expensive disease to treat. But with the advocacy, at least 25 states in this country have a line item in their budget for hemophilia. And that entire amount put together adds up to more than 600-700 crores per year at the moment. So this is a recurring cost. Can we look at a way to actually treat this disease, with gene therapy? So this aspiration and dream started sometime in the early 2000s. We managed to convince one of the early trials to be brought to India. We made an application to the CDSCO in 2002-3. At that time, the CDSCO took 2 years to respond, by which time this trial had closed down. This was an invasive trial where we had to do an arterial catheterization of the femoral artery and inject the vector directly into the liver. Now, this trial was stopped because people had not understood the immunology of this very well. You can carry the AAV vector to the liver, get the liver to be infected and express factor VIII. But when the AAV protein gets broken down and expressed on the liver surface, the T cell comes and destroys that cell. So now you lost your expression. So this was not, considered enough, basic science work. So Nature had this article which urged the gene therapists to go and learn more immunology. So gene therapists went and learned more immunology, and one of the people who learned it very well was a person called Amit Nathwani, based out of the University College London, collaborating with St. Jude's in Memphis, and he published in 2011 and 14 the first successful gene therapy trial with AAV8. Now, it was at that time that I was also trying to explore other opportunities and got in touch with 2 people. You can see some of the stories written there. But this Dr. Arun Srivastava from Florida and Dr. Trent Spencer from Emory, Atlanta, who then, I brought them together and we made a team of CMC, Florida, and Atlanta, trying to develop gene therapy. We developed our own vector. We tested this in a special mouse model. So we chose AAV3, which has the highest tropism for the liver. The problem is AAV3 does not infect the mouse tissue. So where is the preclinical model? Now you have to humanize the mouse. How do you humanize the mouse? 70% of the mouse hepatocytes have to become human. And then these mice then cost $3,000 a piece. So, this AAV3 had to be tested in that. We did that and we showed that this is a great vector. And this was supposed to be manufactured in the GMP facility at the Florida Center, which had manufactured GMP vectors for 8 clinical trials in the US, but they failed. So this was our second failure. First, I tried to do the sponsored clinical trial. Second, I tried to do the AAV-based gene therapy, which got stuck at the GMP manufacturing. But the world moves on. And here is an AAV5 example for hemophilia A gene therapy. This was approved in 2022. Then we also have the example of the AAV-based gene therapy for hemophilia B. This was also approved in 2022. And these are, this is still in the market. Another factor IX gene therapy was approved in 2024. But see what happens to them. So now we have 3 AAV-based gene therapy. The left, Roctavian for hemophilia A, Hemgenix and Bequest for hemophilia B. Bequest decides, and this is Pfizer, no small company, they decide that actually the market is too small. Even though the product has been approved, we will never attempt marketing, and they withdraw it. Hemgenix is still there at $3.5 million a dose. Roctavian was withdrawn from the community 2 weeks ago because after 2 years in the market, there is just no uptake for this product because of various reasons, cost and its performance. And the main issue with that, so today we have no factor VIII gene therapy in the world that's approved and available. From government and academic support from Emory University, and the Minister for Science and Technology obviously hailed this, and they want to see this go forward. So last year we did something beyond that trial. Nobody with hemophilia and inhibitors, antibodies against factor VIII, had been given gene therapy in the world and shown to continue this dream. I'm now associated with the St. John's, a place where they have an extensive network of hospitals. But more importantly, we are actually pursuing the goal of developing gene therapy for the inherited bleeding disorders. We have recently established a collaboration with an Australian group under the Australia-India Strategic Research Fund Grant 2025, where we're going to develop virus-specific T cells and take it to industry to make it available to the people and the centers in this country. So, that is where I want to stop, and thank you again for your attention. I think what I tried to do was to convey to you that if you aspire, if you train yourself, if you have the privilege of having good mentors and a good institution that doesn't necessarily push you but doesn't pull you, okay, and then there are people who will come and find you. If you are doing good things, people will come and find you and you will be able to do. So thank you again for the invitation, for the privilege to be in this meeting today and speak to you with about some of our work.
That was a truly thought-provoking oration, sir. Thank you for so clearly illustrating how translational research can bridge the gap between scientific discovery and unmet clinical needs through your lived experience. I now request Dr. Veer Singh Negi, Director JIPMER, to present the citation and memento to Dr. Srivastava.
Thank you, sir. I would now like to call upon Dr. Kadambari to introduce the chief guest for the day.
I now have the proud privilege of introducing today's chief guest, Professor Narendra Kumar Arora, who's a distinguished pediatrician and eminent public health expert. He is currently serving as president of AIIMS Bilaspur in Himachal Pradesh. He has previously held key leadership positions as president of AIIMS Deoghar, Jharkhand, and AIIMS Patna in Bihar. Until 2007, he was the professor of pediatrics in gastroenterology, hepatology, and nutrition at AIIMS New Delhi, where he established the super specialty of pediatric gastroenterology and hepatology. Dr. Arora has served as executive director of the Inclin Trust International from 2005 to 2025, and now continues as its chief scientist and mentor. He also served as executive director of the Child Health and Nutrition Research Initiative from 2010 to 2014. His career has been dedicated to advancing maternal and child health, infectious disease prevention, immunization, and public health policy. Internationally, Dr. Arora has contributed to several WHO expert bodies, including SAGE on immunization, Stage 4 maternal and child health, and several others. Nationally, he has played a pivotal role in shaping India's immunization strategy through his contributions to NTAGI and by chairing key committees during the COVID-19 pandemic. He has also led the National Certification Committee for Polio Eradication since 2014 and the National Verification Committee for Measles, Rubella, and CRS elimination. Through his visionary leadership and sustained commitment, Dr. Arora has profoundly influenced evidence-based health policy, research, and health systems strengthening in India and globally. Over to you, sir.
Good morning, friends. I'm truly honored to be part of this illustrious group. Thank you very much, Professor Negi and Professor Chitra Sarkar, for inviting me for very illuminating day today. In fact, since morning, what I heard from Dr. Kadambari, the way the research ecosystem has been established and is being kind of nurtured in this institution. And then what Professor Alok Srivastava told us just now, in fact, that sums up what I wanted to say. So I will see, there will be a lot of repetition of what was being talked about in last 1.5 hours. And primarily, my focus of the talk is that how to see research not as outcome, but as an impact. And what Alok told us is a very nice example that research is to be done for impact. And in fact, I was discussing with him that it has to be taken further so that the industry and the wider population in this country is influenced by that. One of the key components when we are talking about research ecosystem is to do a periodic audit also. Because most of our times we got stuck with publications, number of publications. But I think beyond publication, we need to look at how impactful these research publications have been. And also the quantum of grants and the type of grants which we have given, which provides leadership to the institution. And also it takes the institution to a next level, and where this collaboration issue comes up. And all these, I must congratulate you, Kadambriji, that the way you were selling that large number of collaborative research is being done in this institution. And the competitive grants, the amount, which is really enviable, 200 crores, is not a small amount, because in this country, overall is still the research money available is not too much, but it is much better as compared to what was available 30 years ago, which Alok was saying, 93, and those years, he says the first grant was 8 lakh rupees or something, which is today, if you tell somebody ki mere paas 8 lakh ki grant hai, nobody will get really impressed on that. One of the key lessons which I learned from Professor Srivastava's presentation was that one should move from an individual to programmatic research. He did not take it as a simple hematology standalone project, but what he was saying as thinking big. Actually, all of us who are involved in research should think about developing a program. A particular project can be the entry point, can be foot in the door, but basically we have to open up the whole auditorium for that. That you take, so for last 35 years, what I understand is the same area. So whether it is from starting from bench, going up to the community and trying to do the larger societal good, that is what, and this is key issue. And therefore, one within the institution, probably it may be a good idea to have thematic programs and getting a cluster of people together for this exercise. And this research cluster strategy can be very fruitful. And if I could see some of the names, I could not read, it was little distance. that people from multiple disciplines were brought together. And that is the crux, that if we want to have a impactful research program, people from different disciplines have to come through. Because there are, the major benefit is that one is that you get collective wisdom. Whenever interdisciplinary collaboration comes, people give their view. And the second is the quality also improves because everybody is trying to, there is a democratization of the whole activity. And the data sets we get in the process is large enough to draw meaningful interpretation. And also a sense of generalizability comes in. Therefore, this approach of creating institutional research clusters is very useful. You will find wherever the success is there, this is at the core of that. Many times these are implicit, but probably we need to make it more explicit and move forward, because if you have to leapfrog our research programs, probably this may be a useful idea. And that is what my personal experience is, that we have moved forward in this manner, primarily because of building these clusters. Now, I know there is a full biostatistics unit in this. Dear friend is here, sitting here. Probably two components, data science units. Formal data science units in most of our institutions are still not there. In fact, I've been struggling to establish data science unit as a standalone unit, because in today's environment, when we are talking about AI and others, a separate data science unit or department is required, and grant writing cell. Now, grant writing workshops are fine because these are 2 or 3 days. They help. But if there is an institutional mechanism, because a lot of young people they have excellent ideas, but writing a grant requires a sustained and ongoing help. And particularly, I would like to share with our young friends that many times we are very secretive. This is my research idea. It is almost like putting the child around your chest and not sharing it with anybody. It requires a lot of energy and kind of enthusiasm and passion to pursue a particular research idea. So getting input from your friends, and particularly from your so-called foes, academic foes, is very useful. They give you the most useful idea, and that helps. And then this mentored, a kind of a tired mentorship, I think all of us are aware of that senior faculty has to play a very important role. And yesterday, when I was coming from airport, and I was telling that Dr. Vishwanath from gastroenterology, that at AIIMS New Delhi, there is a clause. I hope it can be applied here also. Many times head of the departments are not very generous with younger people. So there, if in 48 hours, the HOD does not forward your letter or application, it is deemed forwarded. Because one of the very good strategies is to sit on it. So what happens that, because mentoring includes not just sitting and working together, it also encouraging the younger people, and that's very important. Large collaborative studies, I saw a large number of collaborative studies being going on in this institution. And I would say that's the crux of impact. When you do collaborative studies, the generalizability improves. Large number of people are participating. You are representing various parts of the country. And immediately you find that these start having policy and program impact. So whether these are observational studies, whether these are cohort studies, trials, implementation research, I'm sure there are, ICMR has recently started a full kind of a campaign of implementation research. Rajiv Bahel has invested almost 750 crores on that during last 2.5 years. And I am aware that some of these implementation research, JIPMER is also participating. These are because, and it is interesting that most of the implementation research has about 8 sites. Now, 8 sites means average district population is about 20 lakhs or 2 million. So 8 sites become how much? 1.6 crores. And you find this is about 1% of the Indian population. So generalizability, you strategically put the sites, and therefore these collaborative studies are very useful. And you find the available networks one should use. ICMR has set up intent network, and there are centers of collaborative centers of excellence. One need to work together and use how they can be. And now population health units are also coming up. I understand there are 37 of these. Within the institution, probably, I think it is very important. We know that in our annual reports, annual kind of reviews, number of publications are are given due importance. But if the impact value, the amount of external grants attracted, patents and innovation and policy influence is also taken into account, that would make more meaningful incentive. And I'm sure many of us must have read recent opinion piece from Dr. Rajiv Bahel, the Secretary and DG ICMR, about this publication equivalence, and it takes care of these 4 or 5 areas. I think that's an important. So rather than, I understand recently the person who got Nobel Prize, her H index was 31 or 32, something of that kind. So many times it's not the number. It is, I think, the impact dimension, which is more important. Is good word? I think it is. Move it. Yeah. Then, so there are these, what should be the process to build the foundation is important. Yeah. Can you do something? I will. Yeah, this is better. Yeah. So if build a foundation, which means a kind of a framework of research in the institution, research governance. I must congratulate JIPMER for having that research cell, and then there is a governance. You showed a flow diagram, and that is really, I think, JIPMER must be among probably the first or the second institution in the country. I know it is not there in any of the aims at the moment. And we really congratulate you on that. And then ecosystem audit, as I suggested, a periodic audit is a useful thing. Research capacity building, we have already we are aware of that, and a lot of work is being done in that. And if we have to have national and global leadership, multi-center studies, international partnerships, and innovation office. And again, you have already established an office which is managing innovation, IPR, and other things. So I think the faculty and students of this place should really feel proud that you are ahead of almost all the institutions in the country in terms of that kind of a system, and that support system has been created or is in the process of being created. Make use of that. And one of the key issue is that if I have my target objective is not to publish only, but to influence health policy, the the health of the people, societal good, how even whether it is a bench research or it is a clinical research or a community research, at all points, if my focus is societal good and public impact on population health and well-being, I think things start moving. And in fact, when presentations are made, one should also say that what research has impacted the national health scenario. Governance, you have already established a leadership council. And so the overall transformation formula is talent, infrastructure, funding, collaboration, and this vision. If we have to put all these things together, then that's the situation when you start making research more meaningful. And therefore, successful institutions build research ecosystem rather than isolated projects. And this is something as a philosophy which has to come up, and particularly INIs are now taking it, because there is this whole vision of Viksit Bharat in 2047, and everybody has understood that without research that cannot be achieved. And I'm sure all of us are aware that in the Principal Scientific Advisor's Office, there is a research fund, and there's plenty of resources have been put in from our understanding, because so far the money for research was minuscule. Gradually the amounts are coming up, and one should use all possible sources, just not ICMR, DBT or DSR. And there has to be a measure of progress and sustained culture change. And one of the best things to my mind is that a dashboard is there, institutional dashboard, which shows publications, citations, grants, patents, policy influence, PhD output, and it drives a healthy competition and peer pressure. So if we have this dashboard, let everybody have it. And so there is an implicit culture of competition, which is healthy. You're not killing each other, but you're trying to see that uski kameez meri kameez se zyada safed kyun hai? Have you heard this advertisement? I think that is very important. The second component, I think I'm really blessed. I'm keenly looking forward to listen to the IIT team, that this medical innovation ecosystem, how is to be built. And because actually the hospitals and large tertiary care or quaternary hospitals are the best ecosystem for innovation. And but unfortunately, in fact, engineering colleges, IITs and Indian Institute of Science have decided to establish medical schools rather than reverse. Probably, I think time has come that even INIs, some of us may start thinking of establishing an engineering college in our campuses. But IITs are there almost all over. Equal number of IITs and AIMS are there, and INS are there. The most important thing is to dig out unmet clinical needs and then systematically identify them. This is very important. And then the impact has to be that we are talking about, we know that during COVID, what happened? Low-cost ventilators came up in very short. A lot of investment was done, but not huge. Prior to COVID, I understand there were just about 21,000 ventilators in the country or something. And now there are over 100,000 ventilators working in various tertiary care institutions. So this, and most of these are now being made in India. Rapid diagnostic kits, again, COVID was an example. And digital triage system for emergency departments. These are examples where, and therefore, and when we look at West, institutions like MIT or Stanford run programs where clinicians map hundreds of unmet needs before inventing the solution. So you have to create an ecosystem where young undergraduates, postgraduates, registrars, faculty members identify these unmet needs during their clinical care. And that should be a trigger for for innovation. And when we are talking about establishing innovation and startup cell, and I understand you're going to start very soon. This is again a very welcome step. I would like to congratulate JIPMER on this because, and I am sure you must have thought about various issues because IITs are much ahead. We know IITs are globally recognized for the kind of work they are doing. And we need to have this idea incubation, prototype development, intellectual property management. I understand there was some discussion on that, startup mentorship also, and industry linkage. So we should not be shying away of working with the industry. I was just discussing with Professor Srivastava that what has been the challenge in terms of their system, their center in working with industry, because ultimately, unless we commercialize and take it to scale, things just what do you call they fall down. The value of death is so we need to have interdisciplinary, so clinicians, engineers, designers, data scientists, and we have to partner with institutions which we normally don't talk. So IITs are there, or now AI research centers, biotech, and particularly the location-wise, the kind of advantage JIPMER has. You can talk to any of these. Another issue, which is a suggestion, and particularly INIs, we have the flexibility to launch this innovation fellowships, and undergraduates and postgraduates can take it up. It can be competitive, and you will see that in next couple of years, things start. Because we get the brightest of undergraduates and postgraduates. And and there are people who just want to pursue clinical medicine. There are people who want to go into private sector, just do practice. But there are some entrepreneurs also who are who have taken up medicine and given the right ecosystem. So this fellowship program, I feel very excited about it. I think we have the flexibility as being an INI, and this is something which can be started. And some seed funding. I saw something like 2.48 crores was the intramural funding. And I understand you can increase it to up to 5 crores, if I'm correct. You can increase that money, and this can be used as seed money for some of this innovation grant. And once we have that kind of a system, I understand IITs create, when they put up incubation labs, they have 3D printing labs, biomedical engineering workshops, data science platforms, simulation labs, and being a hospital, I think we can do all these kind of things without much difficulty, but we certainly need partnerships. And particularly prototyping infrastructure is very important. Because if an idea comes to me, I need to create a structure, a real structure in place, whether it is I'm talking about a kit or a device. Therefore, prototyping infrastructure is required. And then clinical validation environment is right there. So whether we want to do health technology assessment, whether we want to see how it works in a patient group, that facility, some minor kind of modifications are required to be done. And as I said, that engaging residents and students, and particularly through fellowship program, may be extremely useful. Now, technology transfer office is also something. Again, this requires institutional thinking and also a wider thinking rather than getting stuck that how will we work with business community, how I will work with a investor and all this. So whether it is getting the inventions evaluated, whether we are filing patents, I saw that there is a lot of patents have been agreed and the others, but licensing the technology and negotiating partnerships. A young student may not be good enough to negotiate. Therefore, some kind of a very professional support is needed to be provided. If I was correct, somebody from Delhi, you have identified a IPR consultant, and which is providing that support. So therefore, it also means that similarly, negotiators who negotiate business, who help in developing MOUs, whether you are talking about technology transfer, whether you're talking about a business model, all those kind of things, this requires professional support. And connect with industry and capital. Don't be shy in that. And we have now, what is that? Shark Tank meetings. I think you should honor and facilitate a group who is able to reach up to that and get that. See, the whole ecosystem has to be created. This is not just empty talk, and it is not in a sense that we say we have done this. No, this needs to be linked with incentives, whether it is faculty incentive or student incentive. And then regulatory support is equally important, whether it is DCGI, CEDESCO, or other regulatory bodies. If these are biological products, RCGM and all those committees, which are not easy. So one needs support for that. So we talk about clinical observation, we have need discovery identification process. This has to be put as an institutional mechanism. Prototype development, clinical validation, startup formation, health system impact. One has to look at the whole, the dimension is that there is a clinical dimension, where there is a technical dimension, and there is an economic dimension. All these are taken up simultaneously. Now, we should also keep in mind that we may get restless. Within 1 year or 2 years, we are looking for an impact, which is unlikely. It takes time. If we treat innovation as a short-term project, certainly it will collapse. The core lesson is that it is to be treated as a program which is long-term in nature. The life has to be thought about as a long-term ecosystem change. And again, it requires the institutions take care of the clinical component, the research component, the engineering component, and entrepreneurship component together. And it does not come overnight. It is time-taking. So therefore, the governance, administration, the management has to have that patience. And also patience with our own children many times. The person may not do very well in class 12, it doesn't matter. You work with the person, and that suddenly you find by the time that person does a professional course, he becomes much better than the father or the mother. So that hand-holding is required, and that patience is required. So we did a nationwide study on what are the enabling. We have looked at 37 institutions, and we find that what are the necessary factors for developing an institutional ecosystem. Autonomy to the investigator is very important. Encouragement of research, because many times people think research is you're diverting attention from your core duties. No, that is not. And then culture of excellence is very important. And I thought research dashboard is something which we should think it is, and particularly when you have softwares, it can be done on a grant innovation and innovation management unit, which should be functional and efficient. That's particularly, a lot of us, you will be surprised, only 10 or 12% of the medical colleges in this country have a grant management system. Forget about innovation. Even research cell is not there. We have 800 medical colleges. Less than 80 have research cells. And then because the assistance is required to the investigators. And the other desirable factors is mentoring and capacity building, which is being already done. Communication across hierarchy, no barriers based on hierarchy, and freedom to question and criticize. And I was talking about that support system for a younger faculty member, particularly by the heads. Central laboratory facility and innovation. Again, congratulations to JIPMER. You are setting up this central facility. And robust ethical and regulatory review and monitoring mechanism. And then this additional, if it can be possible, there is a personnel for horizon scanning for RFPs, use of technology for grant management, and the other facilities to establish incubators. But a good researcher or innovation, what does it entail? You do develop, you start learning how to build teams and how to manage teams. You also start learning how to negotiate, how to collaborate, and how to translate your research, advocacy and other issues. You start learning. But at personal level, it is quite a toll. Your peer groups may not be very happy with you. I mean, we think, मैंने तो इसका क्या बिगाड़ा है, लेकिन still that sense of competition and a certain degree of jealousy is there. Don't get worried by that. To have your personal life and professional life balance is also not easy because you have to work much harder for that. All of us want to be leaders, but there is a price. Recently, there was a movie called Costa Co or something. This was last year or in 2024. Nawazuddin, and he's a very good cop, but he had to pay a price for honesty, integrity with the family and all those. Have a look at that. It might give you an idea that when you want to become a leader, there is a price to pay, but don't be worried about it. I'm not threatening you, but the fact is that one has to be, if you're ready, you're able to handle it better. So finally, I would say that roadmap for research and of excellence and innovation passes through a deliberate institutional strategy, which is focused on research culture, infrastructure, talent development, funding, and translating discoveries into policy and programs. Thank you very much.
Thank you, sir, for that inspiring perspective on reimagining research in medical colleges. We're sure that your reflections will motivate us not just to produce publications, but to create tangible impact on society. I now request Dr. Veer Singh Negi, Director JIPMER, to present the memento to Dr. Arora.
Research thrives not only through discovery, but through the documentation, through the careful recording of ideas, efforts, and achievements that define an institution's academic journey.
The JIPMER Research Day souvenir stands as a reflection of that journey. It captures a snapshot of the diverse and dynamic research activities undertaken across departments, disciplines, and training levels within our institute.
More than a compilation of the abstracts and reports, it represents the collective intellectual commitment of our faculty, residents, scholars, and students.
We now request our esteemed dignitaries to kindly release the 11th annual JIPMER Research Day souvenir.
Thank you all. May this publication continue to inspire the collaboration, curiosity, and excellence in research.
We now come to a much anticipated segment, the presentation of awards. These awards recognize perseverance, originality, and scientific contribution across levels, from thesis to faculty research excellence.
I now call upon Dr. Sonali Sarkar, convener of the scientific committee, to announce the award winners.
Thank you, Vineet and Agnes. So we have the research awards now. First, we'll start with the junior residents and the PhD scholars. We heard from our chairperson, chief guest, that we have good number of best of the postgraduates are here being an INI. Given the large number of postgraduates and the good quality of work they do, the research contribution is immense. So to recognize this, we are having 3 awards. The first is for a PhD scholar, Best Paper Presentation Award. For this year's award goes to Dr. Namita Patel from the Department of Preventive and Social Medicine for her paper titled Gestational Weight Gain and Adverse Pregnancy Outcomes Among Pregnant Women Attending Primary Health Centers in Puducherry. Results from the Janam pregnancy cohort. Congratulations, Namita, for the great work. The second of the awards is Dr. Shyam Sharma Memorial Award, which is given to the best dissertation among all postgraduates in various departments in JIPMER. For this year, the award goes to Dr. Bharat V from the Emergency Medicine Department. Congratulations, Dr. Bharat. Okay, so Dr. Bharat is not available here. So Dr. Manu, his guide, will receive the award on his behalf. Congratulations to the student, the guide, and the Department of Emergency Medicine. This is a small department, but have made tremendous contributions to the science and research in JIPMER. The third of the postgraduate awards is J.K. Datta Endowment Prize, is given to the best dissertation in infectious diseases. For this year, the award goes to Dr. Aditya Bhattacharjee for his dissertation titled Validation of 2 Prognostic Scoring Systems to Predict Mortality in Patients with Tuberculous Meningitis. Congratulations, Dr. Aditya. And congratulations to the guide and the Department of Medicine. Please step forward to collect your award. Now we come to the more exciting awards, that is the Faculty Research Awards. The first among these is the award for the best collaborative research. So we have heard enough about the importance of collaboration in research, and we are having enough in JIPMER now. The best award in this category goes to Dr. Rajeshwari Aghoram and Dr. Rajalakshmi from Physiology and Neurology departments. Congratulations. The study was titled Effect of 12-Week Practice of Anulom Vilom Pranayama as Adjunctive Therapy on Cardiac Autonomic Balance, Cognition, Psychological Status and Quality of Life in Individuals with Mild to Moderate Parkinson's Disease, RCT. When research crosses boundaries, it actually impacts human health. Congratulations to the team of physiologists and neurologists. The next in the category are the awards where we have a cash prize and a plaque. The first of these 3 awards is for the basic science. This is contribution, lifetime contribution, career award. So this is being given to Dr. Rahul Dhadokar, Professor of Microbiology for the basic sciences. Congratulations, Dr. Rahul. He is a virologist and heads the National Center for Virology Lab in JIPMER. The second award in this category is for the best researcher in public health. This is newly instituted this year, and the first recipient of this award is none but Dr. Sitangshu Shekhar Kar, professor of the Department of Preventive and Social Medicine. The Department of Preventive and Social Medicine has been leading public health research in JIPMER and also in the country, and Dr. Sitangshu is a deserving candidate. His extraordinary contribution in the terms of health technology assessment center in JIPMER. Thank you so much, Dr. Sitangshu. We are proud of you and congratulations again. The JIPMER HTA center actually was received the silver medal, if I'm not wrong, Dr. Sitangshu, at the national level for its excellent contribution. And the last but not the least, the Young Faculty Award goes to, again, instituted first time this year, and the first recipient for 2026 is Dr. Manu Aryan from the Department of Emergency Medicine. Congratulations to the department and Dr. Manu. Excellent work. They head the Center for Emergency Medical Care in JIPMER. That's a national level center, multiple sites across the country, developing model of how emergency medical care can be provided to those who are in need. Congratulations to the whole team. So that brings us to the end of the awards. We'll go to the prizes next. Thank you.
Congratulations to all the awardees. I now invite the Dean Research, Dr. Kadamri, to propose the vote of thanks.
I have the pleasant duty of proposing the vote of thanks for this function. Our heartfelt gratitude to Professor N.K. Arora, the chief guest for today's function, for his mind-blowing message about how to improve research, grounded, yet showing us that the sky is the limit. Thank you very much, sir, for taking time to come and inspire our young researchers. My thanks is due to Professor Alok Srivastava for showing us his incredible journey in the field of hematology, and again, an inspiration to us that hard work pays in ways that you don't expect it to. Thank you very much for finding time to deliver the oration. This is the first Research Day oration, and we are grateful that you have accepted our invitation. My sincere thanks to our president, Dr. Chitra Sarkar, who couldn't be with us here today, but who was a big pillar of support for the Division of Research, and who's always been giving us a lot of encouragement and advice and suggestions. Thank you, madam. Without support from our director, the Division of Research can never move forward, and he's always there, ready to listen and support and provide the needed encouragement. And without him, it cannot move forward. So thank you very much, sir, Dr. Negi. Although I presented the achievements of the research division, this is something that I have inherited. And so the credit goes to those who were there before me, and the way the research division has developed in the institute. The previous Dean's Research, Dr. Sunil, is here. So thank you very much for gracing us with your presence. all the other senior faculty here, the Dean Academic, the Medical Superintendent, other senior heads of department. Thank you for being here. It's good to see you here because I think you will take this forward in your individual departments and help us to move forward. Thanks to all the students, the undergraduates, postgraduates, the PhD scholars who actually are the key people in this entire event. And for the last day and a half, they have been so enthusiastically participating in all the events, the poster presentations, the oral presentations, and they also took part in organizing the event. And so thank you for that. This program would not have been possible, and the scientific content would not have been possible if it had not been for Dr. Sonali, who runs this like a well-oiled machine. And with her calm, soft nature, there's a backbone of steel in that softness. She manages the entire show very efficiently. So thank you, Dr. Sonali. The division of research rests on 4 pillars, the associate deans who work tirelessly. And I would like to personally thank them for helping me get through this first research day. Dr. Subita, Dr. Vikas, Dr. Prashant, and Dr. Nishad. Without them, this division will never stand. The other staff of the research division, particularly Mr. Yuvraj, the manager of the research division, has also worked silently and very efficiently in the background. So thank you. Other support that we have received for today's function is from the IT wing, Dr. Titoria and his team, and all the staff who are managing the transmission to JIPMER Karikal and the Anam campus. So thank you very much. Dr. Lata, who has taken charge of making the arrangements for the stage, the students who compared the function, the students who contributed to the organization, and also who participated in conducting the program today. Thank you all very much. Of course, we have the other support from the horticulture, the electricity department. We have to thank Dr. Ramesh Babu, who hosts this auditorium and takes care of it so that things go seamlessly. Thank you very much. If I have missed out anybody, it's not by intent. I thank each and every one of you for attending this program, and I look forward to our journey together in the division of research. Thank you very much.
Thank you, ma'am. I now request everyone to kindly raise for the national anthem.
Thank you, everyone. We will now break for refreshments and reconvene at 11:45 a.m. to witness presentations by our faculty award winners. I would like to request everyone to remain standing while the dignitaries exit the dais. Request all faculty members to proceed to the multipurpose hall, which is to my left, and all the students to proceed to the corridor on my left for refreshments. Stage layout.
A very good morning to all of you. It's still not afternoon, and we are ahead of time, so starting now. So we are starting with the Faculty Research Awards papers. The first one would be collaborative research. And I request Dr. Rajalakshmi from Department of Physiology to please start the proceedings.
I guess that time is 10 minutes.
Yes.
Is it right?
A very good morning to all esteemed guests, faculty members, and my dear colleagues. At the outset, I would like to thank the jury for having selected our project for the Best Collaborative Award. I'm Dr. Rajalakshmi, Additional Professor in the Department of Physiology, and I'm here to present our collaborative project titled Effect of 12 Weeks Anulom Vilom Pranayama as Adjunctive Therapy on the Autonomic Function, Cognition, Psychological Well-being, and Quality of Life in Mild to Moderate Parkinson's Disease, a randomized controlled trial. So let me introduce our team. So myself from the Department of Physiology, Ms. Usha from Physiology and Dr. Pravatipal from Department of Physiology. Our main collaborating team was from the Department of Neurology, Dr. Rajeshwari Agodam, Dr. Sharbari Basu from Department of Biochemistry, Dr. Maushmi from Department of Psychiatry, and Dr. Harichandra Kumar from Department of Biostatistics. So a brief overview about our project. So we all know that Parkinson's disease is a progressive neurodegenerative disorder, which is characterized by loss of dopaminergic neurons in the substantia nigra. And Parkinson's disease actually causes autonomic dysfunction, cognitive decline, psychological disturbances, and these in turn significantly reduce the quality of life in these individuals. The existing pharmacotherapies for Parkinson's disease mainly address the motor symptoms than the non-motor symptoms, and hence there's a felt need for simple and cost-effective adjuvant therapies to improve the non-motor symptoms and the quality of life in individuals with Parkinson's disease. So Anulom Vilom Pranayama, which is also known as alternate nostril breathing, is a slow breathing technique which is known to influence the sympathovagal balance, the cortical processing, and stress regulation, and this has been documented in various medical disorders. However, the role of Anulom Vilom Pranayama in Parkinson's disease is yet not explored, and hence we hypothesize that the structured practice of Anulom Vilom Pranayama could improve the autonomic function, the cognition, the psychological status, and overall well-being of these individuals. So the primary objective of this study was to compare the change in sympathovagal balance, which we call it as the low frequency to high frequency ratio, in mild to moderate Parkinson's disease patients receiving adjunctive Anulom Vilom Pranayama therapy plus the conventional therapy, which we called as the test group, compared to the conventional treatment alone, that is the control group. And our secondary objectives were to compare the change in the following parameters between the test and control groups, namely the cognition, the psychological status, biochemical markers of oxidative stress, and cardiovascular risk and quality of life. So this was a randomized controlled trial, and clinically diagnosed patients with Parkinson's disease on stable doses of anti-Parkinsonian therapy for 3 months with an MDS-UPDRS score of less than 59. Both genders aged 30 to 65 were included in the study, and individuals with chronic medical and surgical disorders were excluded from the study. So this is a consort diagram which shows the flow chart of study. So patients were recruited from the Department of Neurology and they were randomized into the control group or into the test group. The control group individuals received only the conventional therapy for 12 weeks and the test group individuals received the conventional therapy plus the Anulom Vilom Pranayama therapy for 12 weeks. All the study parameters were assessed at baseline, and again they were assessed at the end of 12 weeks of the intervention. So for the interventional group, so in addition to the conventional therapy, these individuals were administered Anulom Vilom Pranayama therapy at the Advanced Center for Yoga Therapy Education and Research at JIPMER Puducherry. And for the rest of the days, so this was actually administered for 1 day per month. And for the rest of the days, they were asked to practice this pranayama therapy at home. And their compliance was actually monitored using a compliance diary and regular periodic phone calls and messages. So these were the various study parameters which we have recorded in the study. The short-term heart rate variability indices, both time as well as frequency domain indices, indicator of sympathetic and parasympathetic activity, the isometric hand grip test, which is an indicator of sympathetic reactivity, the heart rate response to breathing, which is actually an indicator of parasympathetic reactivity, P300, an event-related potential, a biomarker of cognition, the reaction time, both auditory as well as visual reaction time, the psychological status in terms of depression, anxiety, and stress scores, as well as the positive and negative affect, and the quality of life, and the biomarker of oxidative stress, namely serum homocysteine, and the biomarker of the cardiovascular risk, and oxidative stress, namely the 8-OHDG. So the change in the study parameters were compared between the two groups using the independent t-test or the Mann-Whitney U-test, and p less than 0.05 was considered significant. So the baseline comparison showed no significant differences between the two groups with respect to the study parameters, which I just mentioned. However, when we see the changes in the cardiovascular parameters, the heart rate variability, and cognitive parameters, we found that in the test group individuals, there was a significant decrease in the systolic blood pressure, the mean arterial pressure, and there was also a significant decrease in the cardiac sympathetic indices, and there was a significant increase in the cardiac parasympathetic indices. With respect to cognition, there was a significant improvement in the P300 amplitude and a significant decrease in the P300 latency. Similarly, in the test group individuals, we also observed a significant decrease in the reaction time. So this table shows the comparison in psychological parameters, the quality of life, and biomarkers between the groups. And we found that there was a significant decrease in depression, anxiety, stress levels, negative affect, and serum homocysteine and 8-OHDG. And also there was a significant improvement in the quality of life in individuals who practice Anulom Vilom Pranayama therapy, that is the test group individuals. So let's talk about the proposed physiological mechanisms of this study. So Anulom Vilom Pranayama is basically an alternate nostril breathing wherein the individual alternatively breathes through the right and the left nostril. And studies have shown that right nostril breathing leads to sympathetic activation and left nostril breathing leads to parasympathetic activation. So in our test group, the individuals who practiced Anulom Vilom Pranayama therapy, they actually showed a significant decrease in the sympathetic activity in terms of the low frequency normalized units, which is actually an indicator of sympathetic activity, and also the LF-HF ratio, which is actually an indicator of sympathovagal balance. And they also showed a significant increase in the cardiac parasympathetic activity in terms of HF-INU, which is actually a high frequency normalized unit. So pranayama has already been known to increase the cortical and subcortical connectivity. It strengthens the afferent and efferent signaling, and it also modulates the ascending reticular activating system, thereby leading to improvement in attention, cognition, and neuronal processing. So in line with this physiological mechanism, in our test group individual, we also found a significant improvement in their cognition in terms of P300 and reaction time. Similarly, breath-focused practices enhance the parasympathetic activity. They promote relaxation and also mindfulness, and thereby they reduce the stress levels of the individuals. So in our test group, we also observed that there was a significant decrease in the depression, anxiety, and stress levels, and there was a significant improvement in the positive affect and overall quality of life. Anulom Vilom Pranayama in previous studies has been shown to improve the oxygenation and reduce the inflammation and oxidative stress. And in our study in Parkinson's disease patients, the test group individuals, we also observed a similar effect. So talking about this interdisciplinary collaboration, we from the Department of Physiology, we conceptualized the research question and interdisciplinary framework integrating autonomic, cognitive, psychological, and biomarker assessment in Parkinson's disease. We developed the central hypothesis on the role of Anulom Vilom Pranayama in modulating the sympathovagal balance and improving the neurocognitive and psychological outcomes. We also designed and standardized the study protocol. We performed the autonomic and electrophysiological assessments, ensured data quality and the protocol adherence, and also integrated the interpretation of study findings. We led the manuscript preparation, revision, and the final approval of the publication. From the Department of Neurology, Dr. Rajeshwari Agoram helped us in the clinical conceptualization and neurological framework. Madam helped us in patient recruitment and staging of Parkinson's disease, ensured stability of the anti-Parkinsonian therapy during the intervention, assisted the integration of autonomic, biochemical, and neurological findings, and also helped in manuscript preparation. From the Department of Biochemistry, Dr. Sharbir Basu helped us in the ELISA assays for the various biochemical markers and also helped us in manuscript preparation. From the Department of Psychiatry, Dr. Maushmi helped us in selecting an interpretation of the psychological assessment tools, and contributed to manuscript preparation. From the Department of Biostatistics, Dr. Harichandra Kumar helped us in statistical planning, right from the stage of sample size estimation, data analysis, and manuscript review. So what is the impact of this collaborative research? So basically, this study demonstrates the integration of clinical neurology and autonomic physiology. So this is basically a translational research which links physiology, neuroscience, as well as lifestyle medicine. So the key achievements which we were able to achieve at the end of this project was that it was an interdisciplinary collaboration across 5 departments. It was in fact supported by the JIPMER Intramural Fund, and we really acknowledge that. And it was successfully translated into a peer-reviewed publication, which we have published in the International Journal of Yoga. And this is our publication, which is actually a result of our work. So to conclude, 12 weeks of regular practice of Anulom Vilom Pranayama therapy as an adjunctive therapy effectively improves the cardiac autonomic balance, the cognition, psychological status, and quality of life in individuals with mild to moderate Parkinson's disease. This work highlights the value of collaborative translational research, integrating physiology, neurology, and integrative medicine. Thank you very much.
Yeah. It's talking about a couple of questions because we have some from other institutions also. I don't know if there is any burning questions. Faculty or any students or from team from IIT, any questions?
Really heartening to see that you have taken this multidisciplinary approach. I'm curious to understand, as a medical, how did you feel this transition from being multidisciplinary and moving it into actual interdisciplinary? Did you see a difference somewhere that just across domains it crossed and then you had a hardcore impact what you showed? Where was this transition point in terms of your research?
Yes, sir. So, yeah, initially we started as multidisciplinary work, but then basically I got trained subsequently as a MSc yoga therapist. So myself as a yoga therapist, and that's how I just ventured into the interdisciplinary component of it. So I thought, so basically being the principal investigator, so I took the lead, and designing and everything was from my side. But I thought that there should be a contribution from the clinical side. So though I was restricting myself to basic sciences, but then I thought it's not just correct. So I just ventured out into the clinical sciences, and I collaborated with those departments, and that's how this has come forward.
Just one question, Dr. Rajalakshmi. I see there are a lot of improvements in the biochemical values. Were you able to correlate that to some clinical improvement in the patients?
Yes, sir. That was one of the objectives, but because of the short of time, actually, I couldn't project those results. So we did find out that the cardiac autonomic balance, the LFHF ratio, did show a positive correlation with the biochemical values. In a sense, when there was an improvement in the sympathovagal balance, meaning to say when the sympathetic activity was less, the homocysteine levels as well as the 8-OHDG levels came down. So this was a correlation which we were able to see. So therefore, we could conclude that apart from improving the autonomic functions and apart from improving the psychological status, the Anulom Vilom Pranayama therapy, which is a simple therapy, can also improve the oxidative stress and also the cardiovascular risk status of the individuals. So that was one thing which we could find, but I could not project it because of want of time.
Last question.
Yes, sir.
All these individuals, from the time you measured the biochemical status, did they have any stress or they were all taken at rest? So how did we normalize that kind of or standardize that kind of
So basically, the primary objective was the heart rate variability, and a principal procedure or the standard procedure of recording heart rate variability is to give this individuals 15 to 20 minutes of rest before we actually record the ECG. So this gives a sort of a relaxation for the individual. So 15 to 20 minutes rest for all individuals, and then only we start recording the ECG for 5 minutes, and that has been taken into consideration for the heart rate variability analysis.
The right nostril inhalation producing sympathetic activity and the left nostril AVP producing parasympathetic activity. Can you explain the anatomical, physiological?
So these are actually in the developmental stage. So in fact, now we are planning for a functional MRI study on this. But however, we have actually studies which showed that when an individual breathes through the right nostril, so basically there's an improvement or an increase in the sympathetic activity in terms of low frequency normalized units. And when he breathes through the left nostril, so the sympathetic activity comes down, the LF normalized unit comes down, the LF ratio also comes down, and the high frequency normalized unit actually increases. So as of now, this is the evidence which we have with respect to the autonomic nervous system, but studies are still going on to prove it actually through functional MRI and further studies.
But how does it happen? Why the sympathetic on through the when
yes, sir.
right
So
AVP
exactly
and
the neuronal network, that is what so this is still in the developmental stage, and there is a plausible mechanism which they say possibly this is activating the right side and this is activating the left side, but still we do not know the actual network behind it.
neurologist has an explanation for that.
Actually, I would second what Madam said, that we don't have enough data right now to say what these differences are and why these differences happen. It's just that we observe them. And of course, these are all small numbers and these are not very, these are provided like these small studies. And that's why we are planning to bridge this gap. Based on this, Dr. Rajarashmi will be able to tell she's put up another project with a bigger and better, more clinically hardcore outcomes.
Do you have any questions? Thank you.
Thank you.
So we move on to the next paper. This is a research award we started this year by young faculty. Will be giving his presentation. Very active young department also, as a separate emergency medicine department.
Thank you. Thank you, sir. On this offset, I would like to thank Dean Research and the selection committee for selecting my application. And really nice to be here. And as sir told, really a young department and probably a young specialty for India, but not for other parts of the world. So, a long journey from casualty to emergency medicine, and we are on that path. So the area of research which I've been working on currently is implementation research, system building and emergency care, toxicology, point of care research, and resuscitation science. The period in which I was, the award was basically called forward for the last 5 years, 49 publications, 190 citations, and around 4 extramural grants amounting around 7 crores, and 3 as co-PI amounting around 3 crores, and 3 intramural student grants around 3 lakhs. IR is something which really passionate about since last 2 years. Again, thanks to JIPMER who has been pushing IR. And implementation, if you look at from evidence to system change, but implementation research is researching on how this evidence to system change happens. And we use certain frameworks. One of the commonest which has been used, and that's what we are using in our project, which is called India EMS project, which is a high quality, making sure a high quality emergency care is delivered across the healthcare system. This is a project which is a national health research priority project, which is now running in around 5 districts or 5 states in the country. And these are basically projects which tries to build models, and these models could be translated to various other parts of the country. And we evaluate in basis of adaptability, adoptability, and cost, and what government needs to, where government needs to put money and how much money has to be put in. So it has a bit of costing analysis also embedded into it. So in that research, we have been able to do a lot of things across the country, but I just touch upon what we have been able to change in Pondicherry. We had a very rudimentary system of ambulance system, which is called 108 system, which had a very rudimentary operational area, or what we call command system. We were able to actually enhance it. And this is again in IR, we are the in the side, or near the driver's seat, and the driver is the state government. So we were actually able to develop something called a smart dispatch system, where as soon as a call is received in the call center, the call goes to the call is logged in the call center. Location of the caller is noted down. A geo tagged location is sent to the driver. Driver gets it, and then transmitted on to the EMT who's inside the ambulance, so that they can also note down what they are doing in the ambulance. So this whole infrastructure we have been able to develop in Pondicherry. We are running it now in all the ambulances. This was inaugurated by the Chief Minister of Pondicherry. We were able to actually geotag all the ambulances, try to see if by geospatial mapping, try to see if they could arrive within the first 10 minutes of calling for a help. And we were able to reorganize based on that. So this is another, gain which we have been able to do. Something which we understood is that unless the continuum of care process from community towards the definitive care for any emergency care is not maintained, we lose these patients. So that's where first responders are the key. And this is another initiative. Again, we didn't make it. This was vision of Government of India, where we are trying to implement, and we are trying to see if challenges and how we can negate it. Now we have bolstered it onto district collector's office and the disaster or cell and the disaster management team, who are called Apat Mitras and self-help groups, are basically running it. We have been able to develop a structured curriculum for them for training, and they are now driving. So beyond that, we also understood that people didn't understand certain symptoms they have when they have an emergency, and where to go and what to do. So again, we try to do something where, with the IEC Department of Health, Ministry of Health in Pondicherry, we try to develop these IECs, which are again what we call field testing or validations of these IECs were done, and now has been implemented across. We did facility leveling, and the importance of it. We understood that inter-facility transfers are a big challenge. People were not reaching the right facility at the right time. And to understand this, we actually went to all facilities, tried to do a facility level grading to see whether facilities are ready for managing each of these emergencies, and how has this helped us? Now the next step is towards integrating it as geospatial layers inside the emergency response system, or what we call ERSS, which is a unified number. If you call like 911 in United States, if you call 112, your number is going to the ambulance, and the location where you are calling from is automatically logged in, and it automatically tells you if you have if you have a chest pain, this is the center and this is the nearest center to go to. So this is something which we have been working with ministry, and probably in another 1 month this will be implemented. The next step was to standardize things, and one of the best methods to standardize is SOPs or workflows. We have guidelines, but workflows for each of these different levels of care is specifically not there. And this, again, we have done this nationally. We brought it to the state. With state, we sat together, co-designed, and this is one of the co-designs is some one of the components of an implementation research, and we co-designed these. And now with this push towards improving, state has actually built a state-specific committee, which is called High-Level Expert Committee, which is vetting these, and now putting it in practice in all PHCs, CHCs, and district hospitals in Pondicherry. Beyond that, the project, the implementation research, we've been also been able to push towards quality care, which is something really difficult in a very high stakes environment. But we feel that delivering quality care is what we need to also look at in backend, and making sure key performance indicators are checked. So we have ventured into multiple quality improvement studies. One was trying to see door-to analgesia for trauma patients. Another was trying to see if documentations can be done appropriately. One of it was in point of care. Again, using an IR framework, we did it. Then the next was in point of care research, point of care ultrasound research. You can see on the right side where we are looking at pupillary diameters and seeing if this can help us understand more into trauma patients and looking at predicting RAPDs. We also looked at doing gastric ultrasounds to predict if they can undergo a procedural sedation, which is a routine procedure in the emergency department. Beyond that, we have been also venturing into pain-free ED concept, where as soon as the patient comes, really gets a good relief in pain. 3 trials and 2 got published, where we are both of these are funded, intramurally funded trials, where we have done used nerve blocks to relieve pain. And this basically, you can really see how the pain really sharply comes down when a nerve block is given. Resuscitation science is really lacking, and data from our country really doesn't drive. Very few articles have got into, guideline formulation by International Liaison Committee, which actually gets transmitted on to American Heart Association or other organizations for training and guideline setting. This is one of our first simulation-based studies where we did during COVID time to see whether a kind of a coverall could prevent infection prevention practices could be looked at. And this actually now has got into the guidelines used as an evidence for synthesizing in the 2025 guidelines. Beyond that, we have been also working on other 4 trials in cardiac arrest resuscitation, which some of it is in process of publication and some of it is ongoing. Toxicology is another segment which we have been working on. One of the regulatory trials which we got opportunity to work on, a new drug basically could change how pre-hospital care is done or being delivered for snakebite victims, varispladip. Initial trial was done and in our own institute, and I had opportunity to follow up with a IV drug. And then we also had a state level toxicology management bundle or a training pathway, which we developed through another ICMR funded trial research, where we could actually develop training modules. And now this training module has been actually taken up by the state, and it's now, if you go to any PHC, CHC, we have put this there. We have ready reckoners in these places. So this is something which we have been able to translate again at state level. I feel, as Sir was telling in the morning, from research to, policy, we have been able to actually do this. From whatever research we have been able to do, we have been able to actually advocate and be one of the committee members for the National Action Plan for snake bites, and also developing regional venom centers. And probably on Monday, the India MS project, which I was telling about, is now coming in the post-budgetary meeting where PM will be sitting, and the learnings from this projects basically is going to be translated to policy. So these are the achievements, and I would really thank my research team. This is apart from the residents, the whole research team in the department for being there, pushing boundaries and helping us grow. Thank you.
Any questions from the audience? Okay, if there are none, thank you, Dr. Manu.
Please, sir.
First of all, congratulations. That's excellent.
Thanks.
As part of this national priority research program, as I understand that emergency services are to be put in place from Ayushman, Arog Mandirs to PSC to CSC and that. So have you been looking at component and bringing that smart program so that some kind of a model is developed? Are you part of that activity also?
Yes, sir. Sir, basically the whole project basically looks at continuum of care across various levels of care, and we have so the whole idea is integration across these. So whether if patient ends up in a PHC, what needs to be done and where the patient needs to be going. So we are actually looking at these. We have done facility level assessments for all the PHCs, CHCs and district level hospitals. We've been able to actually develop some linkages. We are doing that only, sir. Basically, the intent of the project basically is to make sure that everyone, whoever gets an emergency, get the right care at the right time at the right location.
Yeah, so it is little more detailed, but I'm still interested because in implementation research, many times we are following the usual Western model of implementation research. So what kind of nudge you seeing so that your operational activities are according to the framework which you have prepared? How do you nudge the system, the health facility manpower to do the things? Thank you.
I think that question is what we are trying to do in IR, where we have multiple methods to understand how well the person or the administrator or the person in the system is receptive, and what we call it as an implementation climate. We look at how they are receptive, what is their gains, what are they looking at as outcomes, what are their thought process towards it. So we have certain ways to understand it. One of those are qualitative interviews. Other is trying to understand from the system also, the signals from the system also, what are the possible ways. And we do it in two prongs, sir, basically, more than two prongs, if I would say. One is from top down and from the other is from bottom up. There are certain activities where we were able to push it from the bottom up, and there are certain activities where we had to actually push it from ministry in Delhi down to the state government. So it depends on what we are trying to do, and it depends on who is sitting there, and it depends on what we call participatory action kind of a research.
Dr. Manu.
Next, we have the pleasure of inviting Dr. Sudhanshu Kar for the Faculty Research Awards from Public Health. Dr. Sudhanshu, please.
Thank you. And good afternoon, everyone. Respected chairpersons and the dignitaries on the dais and off the dais. So at the outset, thank you so much for considering this proposal to be funded and to be awarded. So I'm going to share some of the journeys that I have taken through in the last 16 years in JIPMER, and then we'll look at this. So in 2010, I joined JIPMER, and since then I have been working in 4 different areas, but my primary area of work was, to start with, was NCD. Then tobacco control was added to it. When I came to JIPMER, medical education was another passion that I found. And towards the later part, I jumped into the world of HTA. HTA stands for Health Technology Assessment, as many of us know. So what is HTA? HTA is a prioritization tool. Now we'll try to discuss a little more about it. What is prioritization tool? So when we want to buy something, we have some criteria in our mind. Where should I invest my money? Where should I get the value? So that's when we do it for our own self. That means when we're using our own money, we can be little flexible. We can take a subjective, indicator into our mind and then buy. But when we are trying to use public money, then how do we move forward? So it has to be, we should follow a systematic process. We should be transparent and it should be scientific. So that is what HTA is all about. It is a multidisciplinary process where we try to compare interventions, looking at their, do I get the maximum value of money? And that is where we try to put our money on, because money or the resources are finite. So that's the second part. After having done this scientific process, we generate something called ICER, the incremental cost effectiveness ratio. And that ICER is plotted in something in a ICER plane, where in the x-axis we have got incremental cost and in the x and the y-axis, we have got incremental cost, and in the x-axis, we have got incremental effectiveness. And if the ICER value lies in this southeast quadrant, then we are very confident to take a decision because this is more effective and less costly. And similarly, if it is in the opposite direction in this quadrant, this is very sensitive. So what happens is, then we have to reject the intervention and we should try to go for the standard of care. So when we're doing this, what happens is, how did this evolution of HTA happen? How did we go there? If we look at the number of countries that are using some way of rationalizing money, allocation of money, and the system to be a part of the health benefit package, around 104 countries have a systematic and formal decision-making process at the national level, and India has also started and gone in that journey. We take inspiration from NICE, which is the National Institute of Health and Clinical Care Excellence in the UK. In 1999, this NICE framework was established as a part of NHS in UK, where they look at each intervention, look at their cost effectiveness, and then they decide whether it should go to the health system or not, because it is all our taxpayers' money or public money that is being spent there. So in the similar line, in 2016-17, the HTA ecosystem was framed in India as a part of the DHR network. And then since then, we have been starting to work in this area. So if you look at the DHR ecosystem, how does it start? It has got resource centers, it has got a board, it has got various state health departments, technical appraisal committee. So what they do is, just a minute, sorry. So what they do basically is to get questions from state health departments to find out, to give them the answer whether this intervention should be a part of the health benefit package or not. After getting that question, there is a prioritization committee at DHR which looks at the correctness of the question, whether it is formed properly or not. And then there are these resource centers or technical partners who conduct these studies and give the recommendation. Those recommendations go to board, and then finally the board approves. Once the board approves through a TAC process, what happens is then it goes for recommendation for health benefit package at the NHM level, and the budget is allocated. So the research centers and resource hubs are the brain of this HTA ecosystem who are primarily doing this study. So the objective of these resource centers or hubs are basically three, very simple. The first one, to conduct the economic evaluation or HTA studies, to look at to build capacity in HTA, that is in economic evaluation modeling, and also to look at how do we take it to a policy level advocacy forum. So that's the three basic idea of this particular work. And we have established this HTA center in JIPMER in 2019-20. But before that, we have been attached to some of the work that is I was very interested in this field of health economics from the beginning. So when Dr. Ravi Kumar was there as the director, then we have done some return on investment studies that if 1 rupee is spent on JIPMER, how much we give the output as. So that was the return on investment study that we did in 2014, 17 and 18. We also looked at the point of care device for anemia, like the True HB and HemoQ, whether this can be cost effective or it can be a part of the Anemia Mukt Bharat campaign, which we found to be cost effective, and it was done. And also from clinical immunology department, Dr. Negi had that time thought about looking at rheumatoid arthritis as the cost of illness studies for that, and how do we go forward to it. So these are the sporadic studies that we have been doing from 2013-14 onwards. But the institutionalization of HTA happened in 2019, where the first workshop, following a workshop at CMC Vellore, and we also conducted with some of our faculty members who are sitting here. We went there and we learned about this process of doing the HTA. We conducted the workshop in JIPMER as well. And since then, we have started taking research questions, and those research questions were evaluated systematically through a team of members who are there working with us. And then finally, recommendations were provided. And then in 2024, because of the activities that we did, our resource center was promoted to a resource hub. And in 2025, we were also given the award for the silver medal for performing the norm by DG ICMR and Secretary DHR. So we are still continuing to do this work. So now if we look at the research footprint, we have done up to 40 studies as of now, which were the DHR completed studies are 14, because the studies were allotted to us from DHR based on the questions that the state government. In-house studies are also completed. We have done some in-house studies from the faculty members. We generate our own research question, around 15, and currently ongoing. So total 40. If you look at the areas of the research studies, the health technology assessment studies or economic evaluations were 35. Our team is very proficient in doing Markov modeling, the decision tree, and all those things. But static model, basically compartmental state transition models, economic evaluation studies, costing studies, outcome assessment studies, equity related studies, and adaptive HTA studies as well. Evidence synthesis, which is the first pillar of HTA, were also done in our center. 5 we have done. As of today, we have got around 25 publications from the center. These are some of the publications which have determined the way the decisions should be taken at the national level. How do we look at the value set generation? Then estimating the willingness to pay threshold, adaptive HTA. Some of the faculty members who are present here, we have looked at their clinical questions and also presented it, like the cost utility analysis of dabigatran, hyperbaric oxygen therapy, cost effectiveness of population-based screening, and CVD management. So that's the first one. So the first domain or first mandate of ours was to conduct HTA studies, and we have done that. The second one is to look at the capacity building and training activities. So in this particular domain, we had conducted almost 34 capacity building activities, which is done at the national level, at the state level. We also have integrated the health economics as a module for our MD and MPH candidates. We also conduct workshops for the faculty members for building their capacity, or those who are interested in health economics area. I saw Dr. Arora's slide. There was a section where health economics was to be an area of research and health promotion, and we should be focusing on that. So sensitization workshop for JIPMER faculty. And we are also starting an HTA online course, which is almost 90% over, so that it is, though it is primarily for the HTA-IN scientists who have joined the 28 centers that are there throughout this country, but we'll also try to put it in our JIPMER website so that people can have access to it, and if they are interested, they can go for and learn from that site. The third one is policy impact. The top three policy impact papers, if we can talk about, is to generate the value set that we did for the southern part of India, led by PGI. The CKD in Kerala, whether cost-effective CKD screening strategy should be done or not, should government invest money in that or not? So that was another thing. And in Anemia Mukt Bharat, to look at the digital and non-invasive hemoglobin screening tools supporting Anemia Mukt Bharat. So these are the three policy impacts that Dr. Alok Srivastava was there today morning when we have looked at the emicizumab, whether it is cost effective for severe hemophilia A patients, and we found that the cost has to be reduced to meet the threshold of rare disease, the fund that is given for rare disease treatment of 1 lakh. We have to reduce the cost by 85%, though it is cost saving, but still we have to move forward. So coming to the collaboration, as we do continue doing work, we have developed some collaboration outside India. Look East was the policy that was told to us when we started our journey. So Thailand, NUS, Australia were the places where we have developed collaboration. But University of York, because we also work in the area of equity, so that is the place where equity has got a lot of work done. So these are the areas where we have been doing. I serve in the board of the HT Asia Link Network, which is a network in the Asia Pacific region. And we try to think that what are the things should be done for our region and not borrowing everything from the Western literature. So we also have this DG Care, DG HTA collaboration across South Asian country. Our team members were part of it. The members of Equitap HTA network, where we should not look at efficiency alone. We should also look at how the benefit of those health interventions are distributed across various wealth quintiles. So that is what equity is all about, whether everybody is benefiting the same or some groups are benefiting the most. That is what we are trying to look at. The focus of our area are going to be on that as well. As a part of recognition, that what we got is the Silver Award for the year 2025. Dr. Vinod Paul and Dr. Rajiv Bahal were there in the HTA conclave that every year we meet and look at our performance, how are we doing, how much time we take to complete a study. Based on those parameters, it was done. So having done some studies and also building capacity in the region, we also looked at our SWOT analysis, the strength, weakness, opportunity, and threat of the center. What are those things? Because unless we look at our strength and weaknesses, there will be very difficult, or introspect, there will be very difficult or very little scope for improvement. So the strengths were, we have now a ecosystem is there. There are guidelines, standardized guidelines available, though we have to develop our own in some areas that we are working on. And if you look at this multidisciplinary clinical, we have this, JIPMER has got this unique environment where we have clinicians, we have epidemiologists, we have biostatisticians, and everybody. So when we get a question, we try to generate a multidisciplinary committee and try to discuss those things so that the clinical expertise also included in the modeling. Modeling just can be done without numbers, with numbers, but unless clinical expertise are included in it, it becomes little challenging. There are opportunities, real world data. The state governments are now sensitized to HTA, so they are also asking about this question. So that is one opportunity. Weaknesses are sometimes the time that is allotted for doing these studies are very limited. They want the results in 2 to 3 months' time. By the time framing the research question takes that much time actually. So that is the problem. People get various opportunities, they leave the institution. So starting this PhD program for scientists or extramural grant is a very welcome step where we can retain them for at least 3 to 5 years and they can contribute for this HTA's growth. There are threats that private sector is still not involved. There are different modalities of work there, but this is how the SWOT looks like. So what are the journey? What are
yes. Now, so that we'll have time for the
yes,
question.
So just last slide, sir. So the journey ahead, if you look at, is so we were trying to work on the equity issues, the patient level decision. We are very good at the state transition model, but simulation model, individual patient based based model we are going to work, conduct economic evaluation for complex interventions, newer HTA method like early HTA or adaptive HTA, and continue to build capacity of young minds. Some thank yous are due. The department is very supportive, very conducive for growth of each and every faculty member. I personally thank everybody who have supported in all this endeavor. So taking names will take so much of time, but also the administration, starting from the previous directors, Dr. Ravi Kumar, Dr. Rakesh Agarwal, Dr. Negi, were very supportive. Some of the young minds, you can say young at heart. So they are all there who have contributed to the growth and research questions to all of us. The ecosystem of HTA-IN looks like this. Some of the people need to be thanked, but my sincere thanks goes to my HTA team who are the pillar of our success. They take questions. Dr. Vignesh is sitting here. The other people might be there. I'm not able to see them, but they are the pillar of our strength and ideas. There are some international collaborators with whom we work very closely. And that's the last slide. And I would like to thank here. Sorry for taking a little more time than allotted. Thank you, sir.
Thank you, Dr. Sudhanshu. Since we have run out of time, we have to move to the next paper. This is from Basic Sciences, Dr. Rahul Dodpaka.
Thank you, sir.
Good afternoon, the chair, the dignitaries in the audience, and the administration, the research office. At the outset, I would like to thank the administration and the research team for selecting my application for this award. I would just be very brief about what I could summarize in the small time which was given to collate whatever we have done. It has been a very, very long history. First thing which I would like to show is something which I would like all the young faculty to learn. This was my first research or the MD student whose thesis came out well, and that we converted into a multicentric study. This I'm emphasizing because many times we hear that we don't have a seed grant, we need support from the institute to put up an extramural project. You can do a very good basic work with your MD thesis or the MD student and develop it into a larger study that can be taken as a seed grant. This was a study on the epidemiology of keratoconjunctivitis. This was a local thing, and then we converted into a multicentric 5 to 6 center study. And these were the publications which came out of it. Gist of it is we understood the epidemiology of keratoconjunctivitis, what were the agents. We did observe that the adenovirus serotype, which is commonly, we understand HDAV8 is common, is evolving into other serotypes. Might not have much of clinical relevance as for now, but in the longer run, this would be important. Second thing is about the DHR grant regarding the establishment of state-of-art virology laboratory and BSL-3 laboratory. This has been a game changer. This was sanctioned in 2015. We established the grant in the lab establishment by 2021. It was little longer than expected, but we did finally establish a BSL-3 laboratory. We did get it certified. And I haven't put much data about how the lab is working, but that has been considered one of the top performing VRDL laboratories in our country and has been awarded consecutively for last 2 years as the best performing lab. Now coming to the BSL-3 lab, because of this lab and our performance, we have been included into the BSL-3 laboratory network, which has been established as a part of NOHM, the National One Health Mission, whose idea is to train the laboratories in diagnosis, intersectorial training of human animal samples, so that in case of any outbreak, there is no dearth of places where the samples can be processed. Right now, if any outbreaks are there, there are hardly 1 or 2 labs. Either for human samples, they go to NIV, or for animal samples, they go to Nishad in Bhopal. So the idea of this network is that there are multiple labs which can turn out a faster diagnostic support in terms of outbreaks, and they can support each other. The other field which I have been working on is Orientia susugamushi. This is something which is emerging pathogen for last 1.5 decade. We have worked extensively on this. We had a couple of studies which again were part of the MD theses, one from pediatrics, another from our department. And this has emphasized the importance of strep typhus associated meningoencephalitis. We did go beyond doing only the studies. We understood that currently in the diagnostic era, if, we see there is a dearth of diagnostic kits. So we did go into the evaluation of the locally made kits, and so that they could be procured by the system. On the request of DHR, ICMR and NCDC, we did an evaluation of RDT so that they could take it for their procurement. Further, to take the diagnosis and the quality of diagnosis further, we did establish EQA program, or the Quality Assurance Program. This is the first in our country which we have established. There's nobody, and in fact, worldwide, if we see, apart from Australia, nobody provides EQA for scrub typhus. We further went on to develop novel primers for Orientia susugamushi, which are tenfold higher sensitive as compared to the known standard primers 47 kD, and for which recently we have been awarded a patent as well. Then the other part of work has been with respiratory viruses. We have been providing diagnostic services for the patients of JIPMER across Pondicherry on a diagnostic mode. As well, we have been doing quite much of research with the respiratory viruses. We have established the conventional Sanger and NGS sequencing protocols, and this goes into the national health data, where through a ICMR-led program, this data is fed into the national systems, which then takes a call on how the system has to move. We have also standardized NGS sequencing for influenza B. We are also doing a genomic surveillance and sequencing for the other respiratory viruses of importance. We are a part of a national network for respiratory virus surveillance, where we are a reference laboratory in a 50 laboratory network, where we are responsible for the culture and genomic characterization of influenza and SARS-CoV viruses. And this data then gets contributed to the WHO data for the vaccine candidates. We do culture and give a genomic surveillance data. Further understanding the importance of respiratory syncytial virus, we have been working on that as well. We have had a good study which we published, and right now we are working on the maternal antibody levels and their corresponding levels in the newborns, understanding that a vaccine for that is available, and this basic data might help the government systems understand the need of vaccine in our country. Then another important thing which we have been working for last 2 years is on acute encephalitis syndrome. We are a part of this national network, with JIPMER being the lead site for hospital-based surveillance of acute encephalitis syndrome, which started with 12 sites, has been expanded to 15, and soon is going to be expanded to 20. And this is something which I hear from ICMR is very keenly watched by the DG himself, and it has been presented to the parliamentary panel. This gives us a snapshot data, the distribution of etiologies over time, how different etiologies are seen and across the age. The predominant etiologies what we have seen is scrub and Japanese encephalitis. So this is briefly, I thought I was told that I should be very brief. So this is all I have presented. There is quite much beyond this. Further, where we thought we are a bit lagging is on the sequencing platforms. And we have started taking steps on that. We have right now 2 studies which are lined up. One is regarding understanding of the circulating virome in severe acute hepatitis. And another is for the metagenomic sequencing for the acute encephalitis cases. This is a part of our study where we are trying to use a economically feasible model of nanopore as a part of the earlier study which is shown. Expensive panel is being used. And the new thing which we are going to attempt, we are putting up a project now, is on multiplex bead-based assays for multipathogen detection. So this was briefly what we have been doing. And this all would not have been possible without the help and support of the administration, my teachers, collaborators, and research team. I deliberately did not put photographs because I thought if I miss out somebody, they'll not feel good. So I have been very generic in that. And I would like to thank everybody who's there in the audience, all my friends, those who are here, those who are not here, and for whatever we could do. Because being in the laboratory department, you need to have a lot of support from the public health, from the clinicians, from where we are going to derive the samples. Thank you.
Thank you, Dr. Rahul. I think we're already running behind time, so we will finish with that. Thank you very much.
Many of you may want to question, but hopefully we'll be around. Dr. Sudhan should also get time. So during lunchtime, please make yourself available if you could. That will be helpful.
Thanks.
Thank you, Dr. Pankaj Kundra and Dr. Sunil Narayan for chairing this session. I'd now like to call upon stage Dr. Nishat Plakkal, Associate Dean Research, to present a token of appreciation. Thank you, sir. Intersectoral collaboration, especially between the domains of medicine and engineering, defines modern research. Next, we are pleased to welcome Dr. M.S. Narayanan from the Department of Medical Sciences and Technology, IIT Madras.
His work focuses upon decentralization of healthcare and medical technologies via point-of-care clinically relevant platforms for utilitarian impact in resource-limited settings. We look forward to his insights on advancing healthcare through interdisciplinary research and the power of collaboration.
Okay. So for those of you who haven't met or heard about the IIT team that is here earlier, Dr. Narayanan works with the Department of Medical Sciences and Technology in IIT Madras. This is a newly established department, only about 2 years old, I think. And we have another faculty member accompanying him, Dr. Bajad is also here. And they both are here to outline the facilities available in IIT Madras. And we are proposing a collaboration between the institutions formally also. So there are lots of opportunities for collaborative research and academics with IIT Madras. So I welcome you, sir. Please.
Thank you, Dr. Nishat. A very good noon, one and all. So it's really heartening to be here in this crowd to address some of the bridging strategies between medicine and engineering technologies, so to say. So I'm here with my colleague, Professor Parveen Bazar. So we are from the Department of Medical Sciences and Technology at IIT Madras. And I know how difficult it is hard to hold during an exact pre-lunch session. We'll try to have this as short as possible. So this talk, which is supposed to be here, is stemmed out of a very interesting discussion that we had been having last time with Madam President, Director Sir, Dean Madam, and her 4 associate deans, along with the entire team, when we had been discussing how engineering technologies could serve as a stepping stone to meet some of the current gaps that one faces in the clinics. So we thought, how best could one address this in the given short span of time? And here we have a short presentation on From Bench to Bedside, the vision of translational research, the essence of what many of these prize winners in the earlier sessions, as well as the keynote, as well as the presidential addresses have been going upon. So with this, I think that we will be briefly talking about what translational research in terms of clinical context is all about. And then we would shortly go on describing what an innovation ecosystem would look like, especially in a country like India, where we are in the forefront of many of the emerging technologies in an indigenous context, in terms of Atmanirbhar Bharat and in terms of many other visions that the government is currently having. With that, we will just give a short note on how IIT Madras Bioincubator is a classical ecosystem to promote many of these interesting and thought-provoking ideas to bring them into translational products. And last but not the least, we would just talk a few words about the newly established department so that we could see them as a connect. So to say, in a very glimpsy overview, what is exactly demanding in the current viewpoint is that we are requiring medical technologists, clinical researchers, and physician scientists who are able to understand the gaps that is prevailing in bringing the clinical practices close to field settings, the same way with a very conversant nature in terms of molecular biology, immunology, practicing medicine, as well as many of the recent technologies pertaining to point of care, in the same way as a cardiac surgeon would be comfortable with handling a circulatory rhythm and a cardiac tree. That is the kind of interdisciplinarity and transsectoral approach that one is talking about. And in this context, when we think of translational research, taking the actual bedside practice, especially in terms of the diagnostic laboratories, which are requiring heavy and sophisticated bulky equipment, and taking them as close as possible to the bedside, not just in terms of infrastructure, but also in terms of the rapidity, because in cases like sepsis, where you would want to make the judgment in just a few hours or even less than that, is becoming critical to understand how important this translational research is all about in deriving many of these clinical data and bringing them closer to a communicable way in which both a doctor as well as the supporting team is able to translate them into practice. And for all of this, the entire process might seem to be a bit complicated, starting with preclinical, running on to animal studies, moving on to human studies, and building them into small and bigger cohorts. But this does not happen easy. And like the way we saw in many of the interesting collaborative and prize-winning key talks or flash talks earlier, we try to appreciate the whole sum of the interdisciplinarity in terms of supporting teams, what is currently missing in India, not just in terms of collecting or collating data, but also in terms of clinical management, be it project management in terms of clinical practices, be it research management, clinical research management, or so as to say the wholesome clinical laboratory management in bringing all of these closer together. So with such a hint note, one also needs to have a closer team dynamics, which became evident, especially in a setup like JIPMER, what we saw in the current or the earlier talks as well. So with all of these, one goes closer to reassured criteria put forth by WHO, where it is not just the sensitivity or the specificity of an assay or of a readout platform that we are talking about, starting from the most famous pregnancy detection kit, the lateral flow kit, what we know about until those emerging technologies that came up in terms of the recent pandemic, right? So all of these border upon many of these reassured criteria features, ranging from having a real-time connectivity and running on until delivering the results as soon and as effective as possible to the end user, namely both the doctors as well as the patients. And how all of these can be done is in terms of addressing the critical nuances that brings the basic elements of fundamental research and moving them closer into a translational aspect where institutions like JIPMER and institutions like IITs come closer together and move on to render an effective solution towards clinical practices in both clinical as well as field settings. And for this, one as a medical professional and a paramedical professional needs to understand the end users and the key stakeholders to which the wholesome of these research would be delivered at, starting from the researchers and clinicians, but also running on until the policy makers and the general public, so as to say. And to bridge most of these gaps, a key success comes in terms of point of care devices. It was once again very delighting to see in earlier talks that JIPMER makes quite a lot of attempts in order to bring some of these point of care devices close to field practices and to real-time scenarios. And what is actually missing here is that the time ramp between many of these steps, what we see here, starting from sample processing on to the running the actual assay and the result collection, need to be as quick as possible in terms of having a proper handheld device that can render effective solutions to both communicable as well as non-communicable diseases wherever feasible. So with many of these, the translational aspects running across sectors and across different technology readiness levels, which I'll explain in the next slides, is becoming the key factors that one as a medical or a paramedical research professional needs to focus upon. And to understand most of these research innovations and research push, especially in higher education institutions like we see here in the country, stems from the fact that post-independence, India has been trying to position herself, especially with the West, not just in terms of productivity. We, being an agro economy, have also started to focus a lot on industry as well as medical product development, the success of which we see in many sectors, including defense. So the medical gaps that are present in addressing the defects that is still to be addressed in terms of these defense sectors is quite vast, but still comprehensive. And in order to do that, we, being proud of contributing to the country's and to the global's largest population in terms of many of these professionals, is currently supported by a huge number of departments. Because what often happens is that people from engineering scenarios fail to look at the medical funding agencies and vice versa. But many of the success portfolios in terms of the research grants become evident when these medical professionals join hands with engineering or technological professionals and try to produce as many results as possible in terms of effective devices. And that is what many of the departments of science and technology and the supporting funding agencies are trying to deliver, especially in the recent post-pandemic scenario. And when we look into that, the current change in higher education institutional scenarios is starting to take a tinge, especially to have and impose an essence of creativity among researchers. What do we mean by that? When you look into the new education policy that has been recently launched by the government, you will see to that, in addition to the rote memory, what has been traditionally practiced in the British education system has been, giving us constant push in terms of impinging an essence of creativity and inclusivity in terms of ideas, in terms of innovations, and in terms of broader knowledge that one can take forward. So if you look a bit deeper, what we see here is higher education institutions like JIPMER in terms of medical education as a cradle of innovation. And here it is not just the role of the students as well as the researchers, but equally significant is the role of faculty who can come closer together. the prominent evidence stemmed from the fact during the pandemic scenario when we saw the hardcore research laboratories getting transformed as biomanufacturing hubs, starting from simple sterilization solvents running on to point-of-care devices, therapeutic nanoformulations, etc., where most of these push stemmed from academic institutions moving slowly on to product development portfolios. And that is exactly where the distance between academia and industry is brought closer by appropriate inclusion in teaching methodologies, say in terms of medical entrepreneurship or in terms of technology transfer, IP education, etc., and giving them a huge societal impact. So we hold, as medical, paramedical, or engineering professionals, a huge sense of responsibility also to give back and impact society in terms of product and not just in incurring the education for which we are actually here. So with that in the background, when we think about ecosystem, what we often realize is a mix of biotic and abiotic factors. So one tends to notice the huge turtle here in addition to small fishes, but what is also holding them is these abiotic constituents of the rocks, the water itself, etc. The same holds true to a proper innovation ecosystem when we see in the country that when you have ideas stemming up, it is not just the ideas getting hand-holding in terms of incubation support, in terms of establishing proof of concepts, and those ideas getting some preliminary results in the laboratories, then meeting appropriate people, getting proper fund, discussions or brainstorming over a cup of tea, and all of these getting a proper ecosystem concept, moving on to an interfacing dynamic that moves us closer to United Nations Sustainability Development Goal, especially for things like medicine, moving closer to Goal 3, good health and well-being, and many others that includes the concept of One Health running between humans, animals, and the environment, right? So with all of these concepts, this complicated, we'll get back in a minute to simplify this to an Indian ecosystem. So this is an example from a Singaporean ecosystem where you see that for an idea to get closer to a product, it involves a lot of stakeholders, including corporate sectors, government sector, academic sectors, co-working infrastructure, spaces, etc., which are offered by a plethora of parties and stakeholders. But then the connection, what we see here, is unfortunately not linear as depicted here with this flow diagrams. Nowadays, you also see that educational institutions collaborate very strongly with corporate sectors, and there are public sector undertakings that are happening. And education sectors also require support of media to bring the required visibility and so on and so forth. So with all of these, I would like to highlight here a simple difference between the research innovation push in India across the West. So what happens here in the Western countries is that most of these ideation concepts, when it strikes a student or a faculty, is incubated, molded into a clumsy project, and then landed upon a startup or as a technology is handled by a single entity. So here it is a one unit functioning, which is happening by something called as RTO, Research Technology Organization. So it is an end-to-end pipeline, which is readily available to both students and faculty to push all of this forward. But unfortunately in India, what we have is broken modular aspects where one runs to an incubator or to an accelerator or to a faculty's laboratory in order to get many of these established into a product portfolio. So with this in background, when we think about the actual process of how a deep startup technology or a medical startup technology is going to happen, you have most of these prototypes and customer discovery preceding what is happening in the formation of what we call as a minimum viable or a market viable product to have a strong business model. So many of us have wonderful ideas that can come forth, like we saw in the earlier presentations, but how to take them into a scaled up scenario, how to get supported in terms of technology transfer, where you can monetize many of your ideas into actual product portfolios in terms of revenue generation. And all of these happens with support of entities which range from simple research laboratories at your own educational or research institutions, running on to incubation units and moving up to accelerators that can push them close towards product development. And from our humble experiences, we also noticed
that at points of time, it is also important that you pivot. You need to take turns when you realize that certain things are not working, instead of getting stuck there. And not just that, you repeat, iterate and reiterate the concepts when you want to establish the proof of concept technologies. And this established protocol here for a clinical startup or a medical product startup is running across 9 technology readiness level, starting from a simple ideation towards establishment of certain proof of concept results, running on until a prototype, and then establishing and validating them in proper clinical settings, where at the end of the day, you have a point of care device or a proper diagnostic or therapeutic product at the end, what we currently see in the market. So where you see yourself in this TRL stage, in this TRL ladder, is an important question that any investor or any collaborator is going to pose to you. And that is the reason why we wanted to flash this TRL stage in front of you. And here, another thing we would like to humbly tell you all is that it is not the processes in the research lab or in the incubation that is going to take a huge pitfall. But unfortunately, these are the transition points where one moves from the ideation to pre-incubation or from incubation to acceleration, etc., where people take a step back. That is because the hand-holding, the guidance which many of these modular units provide do not educate them necessarily their path towards the next step in terms of identifying a potential incubation unit, or in identifying a partner, a venture capitalist who can support them, their scale up. When it comes to medical product portfolios, we are easily talking about a few tens of lakhs to a few crores of rupees, right? And such a huge investment is going to fail if you do not get a multi-stakeholder support. And here, I would like to just show IIT Madras ecosystem as an education cum research institution, where we start running from simple research facility to institutional research centers, moving on to national research centers, where you see the diversity running across a cancer tissue bank, a nanophotonic or an electromechanical system, and to water or wireless technologies, so that all of these associated research aspects come closer, become one in a melting pot, so that the researchers do not have struggle to move their path forward in their journey of research. Likewise, there are also some other entities, including Industrial Consultancy and Sponsored Research and Gopal Krishna Deshpande Center. This is very interesting, and Center for Innovation. I'll spend 10 seconds in each of these. Gopal Krishna Deshpande Center is very important because it is not just for the IIT community, it is also open for anybody who wants to move their research front further. All you need to do is to have an academic mentor. You need to have a faculty in your entrepreneurial term, and they do not teach you how to convert technically your idea into product. They do not teach you how you need to fetch an investment. All they do is throw you harsh into the field for a 2 months period, where they give you a simple question, whether your idea makes sense to become a product in the market. All you need to do is to talk to hundreds of people, make interviews, come up with a conclusion, where you will spend 2 months of your hard-earned time to just realize whether your idea is worth translating into a product at all or not. 2 months seems to be a big time, but believe me, across a time span of 3 to 4 years, what you will be spending in a product development, if you are sure in the first 2 months already that your idea is going to become a product, that's worth it at all, right? And then CFI. So this is something we want to suggest as a model which other education institutions can build upon. So all this is a plug and play match of different toolkits and technologies that is thrown across to the current students and researchers of an education institution. We are talking about a space like this auditorium, where in one corner you have some mol bio devices, say a PCR, an electrophoresis unit, etc., and then a sterilization counter, and then an incubation or a microbiology cabinet, and then somewhere where you can have some immunological test run. All of these in a single span of a current, divisible time frame, as well as in a clearly defined space where both student and faculty can just freely walk in and plug and play their research ideas to have initial proof of concepts with which they can convince the funding agencies, for instance. And all of these are very essential for us as a country to move forward in our entrepreneurial journey. And there we have Research Park, the IIT Madras Research Park, what we call it, with a model built from Stanford and MIT ecosystems as country's first research park, which has brought in all the stakeholders, starting from very big industries like Pfizer, Saint-Gobain, etc., and to centers of excellence, which are run by ICMR, DHR, etc., to academic IITM department faculty, to very many startups, which range from faculty startup, student startup, women startup, and all of these coming together, hosted in the same corridors, in the same buildings. The main idea being they strike upon each other, upon walking, upon stalling, upon talking, etc. It's not always that startups learn from big industries. Believe me, many a times industries and big academic centers also learn from student entrepreneurs as well as faculty entrepreneurs. The thing being that no industry wants to invest crores and crores of rupees just to have a big nanoformulation unit or a therapeutic or a diagnostic device unit set up just like that. They wanted to have a feel for the hiccups, a pulse for the problems faced across traversing these lines of journey. And that is what many of these research park ecosystems offer you in talking to each other and trying to understand what it is about. So these numbers give you a rough idea of the magnitude of the space as well as the operation we are talking about. And within the research park, you have several incubation units, incubation cell being the nodal incubation unit, where we have graduated. Now the number is close to about, we have incubated close to 300 plus startups, out of which 100 plus have graduated to market. Meaning when we say a startup has graduated, those have developed a product which has already gone to the market and they are making a decent revenue with these products. Okay. And it is very heartening to see that health technology and med technology is on the rising boom compared to many other domains of startups, what we are seeing. And when we say ecosystem, these are several kinds of incubators, for instance, in the research path, starting from bio incubator, medtech incubator, healthcare and technology incubator, rural technology incubator. That's very important because in tier 2, tier 3 cities where the public health centers do not even sometimes have a first-hand feeling of electricity or any other, infrastructure facility where you can run a centrifuge and separate your red blood cells from your serum or plasma. So all of these give a push for battery operable devices and many other such things which can move all of these across. And when I told you last time, the Singapore model will be simplified. So this is what we are talking about. You get support from a lot of government agencies. You get support from corporate social responsibility grants of many industry partners who can come forward, public sector undertakings, and then you have many other miscellaneous partners and mainly investors who bring in the money. All of these parties go hand in hand. Here are shown the examples operable at a simple IIT Madras incubation cell, but I'm sure that entities like JIPMER and many other medical and paramedical institutions can easily come up with very such models which are still comprehensive and easy to be operated. And bioincubator, I'll finish in 1 or 2 minutes with bioincubator. So this is especially for bio and biotechnology based divisions where it's close to 25. You can ask me, you showed us numbers of 250, 300, etc. But when it comes to bio or medtech, that boils down to almost 1/10 of that. The reason being the gestation period for deep tech, medtech, etc. are quite high. When we talk about SaaS, software, IT, etc., we are talking about a span of 1 to 1.5 years. But when we talk about medtech, biotech, health tech, etc., we are easily talking about 3 to 4 years of gestation period where hard-hold hand-holding is required in order to move products forward. So with all of these in the idea, so you usually have, this is just for you to have an idea of how an incubation space looks like. So you have co-working spaces. You have spaces where the companies sit along with establishing their proof of concept idea. And once they grow up, they take individual cabinets and then they have access to many of these basic and fundamental infrastructure units, which then moves to the next level of high-end sophisticated equipment leading from fundamental translation of research to a basic product development. So ranging from, again, molecular devices, pharmaceutical devices, toxicology testing, so on and so forth. This is an important slide because this is easily just 1 to 1.5 months of time frame you will invest to realize whether your ideation can go on into a product. So this usually goes through screening committee like any other committee meeting. But what I want to show you is that for you to start a startup, for you to kick off a startup, you don't need to have, wonderful funding and a big team already with people. All you need to have is an innovative idea, a spark in your mind, a tinge of creativity that's going to propose you a team. You don't have to have a team, but all you need to know is, like the collaborative research prize-winning presentation we had, you need to know whether you need a biochemist, a statistician, an epidemiologist, who needs to be there in your team, a financial manager, and you need to propose that team to check the feasibility and whether you have the potential to get all the money you want. So with such of these things, these are some simple products that has been spun out of IIT Madras ecosystem. So this is a basic mosquito trapping device. You don't want to use the chemical, loaded these devices that we use currently at the home in terms of coils or in terms of liquidators, because potential carcinogens. So they came up with a pheromone based device that is just going to trap naturally the mosquitoes, and at the end of the day you have a mosquito collecting tray where you can remove all of these from. Likewise, for veterinary diagnostics, simple lateral flow based tests, and then immunostimulants, which are based upon natural food additives for animals. And here you have polystyrene substituted natural polymer based bags, etc. So most of these are spinning out of simple ideas. And this is interesting. What you see here is a simple tissue paper. And once you dissolve this in a glass of water, this water can fertilize almost an acre of land. So here you are avoiding sacks and sacks of chemical fertilizers. The technology being, many of these nitrogen and phosphorus fixing bacteria have been trapped in the nanopores of the simple filter paper, what you had just seen. Likewise here, this is the mosquito trapping device, what we had talked about. Maybe just in 2 seconds, I'll wait until the mosquitoes are trapped.
Mosquito comes for its food near bog orchard, the smart robot catches them and puts them into a suffocation chamber and kills them naturally. You can actually see and measure the number of mosquitoes caught and killed in your home on a daily basis.
Good. Yeah, hope this suffocation chamber was not like my talk. So I hold it to the next one. So especially for the agencies that want to take this further, here I would just like to give some examples of the funding possibilities available. BIRAC is a very potential agencies which support a lot of translational research, and that can be for the institute itself, where one needs to establish an incubation unit which is supported by the BioNES scheme of BIRAC. And next, when it comes to early stage innovations, especially EUA, Sitare, and big grants, we are talking about tune of 40 to 50 lakhs of rupees here, running onto 50, 60, etc. And once you have some proof of concept established, we are talking about 1.5, 2.5, 3 crores of funding that can come up with late stages of funding. And then you also have possibilities to establish accelerators, which can bring your incubated ideas and concepts to the next level of product translation. Okay. And with many of these, we at IIT Madras ecosystem have managed to have an early translation accelerators. This is just to show you that academic or research institutions like Shankar Netralaya, Central Institute of Brackish Water Aquaculture, Murugappa Chettiar Research Foundation have come up with some ideas. For example, isolation of an eye protein, which is both therapeutic and diagnostic, which was later picked up by Sun Pharma company. Likewise here, bacteriophages, which can affect bacteria that are causing damages to shrimp so that the aquaculture is not affected. So a natural therapy that was later picked up by Tata Rallis. And then here, an alternate to biopesticide. All of these cannot be naturally welcoming for an industry to take it directly from an academic institution or a research institution. In between, you need an accelerator or an incubator to scale up and test these ideas to hand them over. So you guys can also come up with ideas of acceleration units where you can test the scale up of your concepts and move it to the next step. And these slides, I want to show that once again, the booming power of medical and healthcare technologies, where we can all come forward in giving back something to technology transfer. If you look at strategies that are adopted by universities and higher education institutions, you see that there are a lot of ways they are trying to push their research outputs outside. But then at some point of time, like it was shown in the previous slide with HTA, institutions also spend a lot on R&D. But what? The proof of the pudding is in eating, right? So they also get time to get back, and that is exactly where, in terms of technology transfer or IPs, that people have started giving back to the education institution. These are all humble tunes, few tens of lakh to a few crores, but this is where we start. You step forward and then you move forward slowly to a progressive march. Last 2 minutes I'll take to pitch our department. So We are an upcoming department, an emerging department, 3 years old department who want to bring engineering closer to medical practices. So here we try to groom physicians, scientists or clinical researchers and bring them with especially the strong background where Chennai, including the close proximity to Pondicherry, is a hub of medical tourism with a lot of hospitals in and around. And with such a scenario, we would want to collaborate with of other hospitals in establishing many of the diagnostic, therapeutic, modeling and a variety of other technologies which take cellular and molecular physiology, moving closer to functional physiology and running them into a practice of clinical physiology. That is the transition what we envisage in the next few years with many of the upcoming centers of excellences that we want to do in collaboration with institutions like JIPMER, for which both in terms of R&D as well as in capacity building, we are awaiting a lot of other specific collaborations to happen. So we have a BS program, the first of its kind in India, in medical sciences and engineering, and we also offer MS, and there is an MD PhD what we are currently offering with Ramchandra University. So the MD part, they do it at the medical institution, and then these people come to us for a PhD where they can develop newer emerging technologies. So with all of these, the students, they cover the fundamental aspects of medical as well as the other relevant sciences in the beginning. And then we move on to the actual aspects of how many of these could be bridging the essence of either the device development, the imaging technologies, the diagnosis, the therapeutics, the modeling, and all of these in variety of fields. So we have some of the equipments, first of its kind in India. So to mention the 10x genomics for spatial biology. So we have the Xenium, Chromium and Visum platform and a pipeline for complete tissue processing in an automated way and a high content screener for a variety of in-house, in-plate imaging, diagnostic imaging, as well as therapeutic imaging so as to happen. So the entire essence of this talk or this discussion would be fruitful if we realize that innovation is not the responsibility of just academic or R&D institutions, but it is a responsibility of each and every one of us to take the country forward in terms of translational product development, which is the key to show ourselves and to position ourselves in this extremely competing and challenging global scenario. And for all of these, once we make ourselves aware of what are the strategies that are available in terms of tech transfer, patenting, IPs, ethics, so on and so forth, moving slowly, joining hands between academia, industry, as well as clinics, so as to say, and then taking them step by step in order to establishing a strong innovation as well as a research hub in terms of either product development or in terms of actual practice that goes directly to the general public. So with this, I end the talk with a small note on Avaya's verse. Aridu aridu maanidaradal aridu, maanidarayinum aridu, oon kurudu sevidi pedu nikki pirathal aridu. To be born as a human is rare and rare. Even more rare is to be born without any defects. So this highlights the very essence of medical and healthcare technologies, what Avayar, a Tamil poetess, said several centuries ago. And I think that we are all blessed in order to contribute in our own humble ways for a potential product development in this area. Thanks. Okay.
We can take a few questions, maybe 5 minutes. If faculty or students have any questions for Dr. Narayanan, we can.
Good. All clear, nothing clear.
Dr. Arora.
Please, sir.
Thanks, Dr. Narayan. Very practical point of view, how IIT Madras and JIPMER actually work together. You have given a broad, but want to, will it be good to have these incubator cells located in JIPMER, or how you envisage this kind of a, and the MOU you are going to sign, what is the nitty-gritty of that? Can you?
Thank you, sir. That's a very essence of the entire discussions we have been having so forth. So we we would just like to propose humbly to you that we can foresee this in 3 strategic divisions. First one is an R&D. So within R&D, we can take up specific questions like, the ICMR car modalities, where we can have a hub and spoke model or a central thematic area, which can depend on the specialization of the departments and the faculty on hardcore R&D areas. And the second one can be the innovation arena, which can come up with the actual exchange of knowledge in terms of establishment of an innovation hub in JIPMER itself, because we can always, you are most welcome also to utilize the facilities. But at the end of the day, in the long run, if we look, I think that becomes more utilitarian if we have the actual innovation center like IIC is being established here for JIPMER, where we could offer support both at a capacity building level as well as in terms of exchange of knowledge as well as personnel. Third, last but not the least, the actual training modalities. So we can have potential emerging tools and technology areas identified where we can have the clinical part of the training being done here and the technology part being done in IIT Madras with active exchanges in terms of workshops, symposia, conferences and whatnot. Thank you. Okay. So you're all most welcome to use our facilities. Sorry, there's one more.